Yeah. So the main aim of this structured design is to transform the transform whatever the results that you have obtained from a structured analysis, that is actually the DFD representations we have discussed in the previous slides, right? So that DFD will be converted into a structure chart. So that is actually as part of structured design. Okay. So as part of structured analysis, we get the DFD representations, right? So a structure chart represents the software architecture where you see, the system consisting of various number of modules, right? And where the module, calls the other module here. Okay. So, and also we pass certain parameters from, these modules, they pass parameters among different other modules, right? So now the structure chart representation, whatever it will be come as a outcome or the output of this structure design. So that will be easily implementable by using some programming languages. Okay, so here as part of your structure chart, what you going to see? So you see certain number of module. That means you are going to see the module structure of the software or the system. Okay, and you see some interactions between these modules, as well as you see some procedural aspects. That means what sort of functionalities are being achieved. Usually, what sort of functionalities and all those may not be represented, what functionality, because they are part of within the modules, right? But usually you will be going to see what sort of data being exchanged between these procedures. Okay, so that is what you can see. Okay, so now very basic building blocks of this structure chart here is so the rectangular box. Okay, so which represents a module. Okay, and this module, this rectangular box is annotated with the name of the module. Okay, so let's say process order may be one module. Okay, so that will be represented by a rectangular box. Okay, and you have arrows between two modules. Okay, so during execution, when a particular high level module is going to call to the lower level module, right? So that is what exactly represented by a arrow. That means the control is passed from that particular high level module to the lower level module. Okay, in that particular direction. So that means the root module is calling the process order module. Okay, and then the root module is calling handle indent. Okay, and then handle query. So this is that the high level calling to, and by a arrow. Okay, so it says that how the execution control is moving from one module to the other module. Okay. So along with this execution, so you can represent by the data as well as an arrow over that particular edge, which will represent data flow. Okay, which will represent data flow. That means here you can see, so when the root module called this process order module, and after after this module is executed, now it is sending back some data, order data. Okay, so back to the root module. Okay, so this is what exactly says that the data flow from process order to the root module. Okay. Now the library module represent frequently called modules. So maybe here a rectangle with double side edges. Okay, so maybe you can see this is the module. So this is the module actually if it is frequently called. So in that case, you can represent that particular module with double side edges. Okay, so that it can represent that also. Okay, and diamond symbol represents one module of several modules connected to the diamond symbol is invoked depending on some condition. So now this diamond symbol actually going to represent that, when certain conditions are or certain condition is met, then this process order module is called. If some condition is met, so then the handle indent module is called. If some condition is met, then handle query module is called. That means it is going to represent some conditions are involved. Okay, so that is what. So, but what condition is there? So that is not mentioned as part of this. Okay, so your diamond symbol represents. So now, so one module is calling another module when some condition is met. Okay. Now, a loop around control flow arrows denotes that the concerned modules are invoked repeatedly. Now, here, when you see this sort of loop over this particular edges, right? So it all represents these are the modules called repeatedly. Okay, but how often these are called? Okay, maybe 3 times, 4 times, 6 times, that sort of information is not mentioned. I already discussed this thing when I had a discussion on software design phase, where I talked about the structure chart already. So again, I'm just repeating these things, right? So now here, so this says that there is this particular root module is repeatedly calling these functions. Okay, clear? So as you can see, so there is a root module, and then you have a module A and B, let's say. So you can see something like this. Okay, so like let's say module A invokes module B cannot invoke module A, so that cannot be. You should always be going to represent through the arrow, right? So that is the way that you can say. So if A invokes module B, that doesn't mean that B is going to invoke A. Okay. Main reason behind this restriction is consider modules in structure chart to be arranged in a layers or levels. So that is the reason why. Okay. So that means the lower level modules, they are not going to call to the higher layer modules. So that is not allowed. That is the reason why. So you do not have it doesn't allow any symmetry. Okay, so that means A is calling to B, that that means B is not going to call A. Okay, so that is not allowed. So always the higher level modules, they can invoke the lower level modules, but the lower level modules, they will not invoke the higher level modules. Okay. So this way, okay, you can see. So that means this this is very bad design. Okay, why it is a bad design? Because you see the M5 module is also calling M1, so this is not allowed. Okay, so M1 can call two different modules, that is fine. Okay, and it can also happen maybe M2 and M3, they can also call to M6, that is also possible, but M6 should not be allowed to call M3. Okay, so now, right, so as part of your structure chart, as we already discussed, right, so a module calls another module, right, many times. That means there is a repetition allowed, but how many times it calls accurately or exactly, so that information is not presented, okay, through the structure chart. So that means so in what order also these modules are called. Okay, so that is also not represented. Okay, you cannot tell that whether the root module should call the first one or the second one or the third one. We cannot say that also, because that order cannot be represented through these structure charts. So usually as part of this transformation of DFDs into structure charts, so there it involves two strategies. So the first one is transform analysis and then transaction analysis. So we'll talk about these two one after the other. So when you going through these two things, so usually you will be able to successfully transform any DFD model into a structure chart. Okay. So part of this transform analysis, so so usually what we try to do here is we try to divide whole DFD, whatever the DFD that you have, we'll try to divide them into three different types of parts. Okay, so one part will be the input, the other is the logical processing, and the third one is the output. So that means input, processing, and output, we try to divide them. So usually, so input portion in the DFD, actually that what it does. So that means it processes it takes some input data and try to make it try to convert that physical data into some sort of logical form. Okay, that means you can think of like when a system, so when that particular system is inputting certain number of characters using the terminal, right? Now these data, after the characters are read from the terminal, and these things should be stored in a database or the tables, right? So now that means what you are trying to do. So whatever the physical input that you are getting, that is actually getting converted into a logical form. Okay, so that is what we do as part of input portion, right? So this is also sometimes called as efferent branch. Okay, so possibly you will have more number of efferent branch. That means because you possibly give more number of inputs, okay, to the system. That is the reason why you going to see this, right? And then so you have output portion of a DFD. So that is what is exactly going to do. So again, whatever the output data, okay. So whatever the output data that needs to be given to the external entities, right? So that means the logical data that is there in your system, okay. So that is again will be converted back into a physical form. Then entity can easily understand. So maybe you can, like, the arrays whatever you created, now that arrays will be again converted back into characters, because we maybe the characters we will be able to understand them, right? But you will not be able to understand the ASCII value of those characters, because those values are being stored in the logical database or in the data structures, right? So now using data structures in your computers, right? So that is what we say. So this is what we call as efferent branch. That is the efferent one input, and this is what we call as efferent. Okay. So remaining portion of the DFD called central transform, because that is the processing part. Okay. So you got the input and you got the output, and then the third one is the central processing, right? So derive structure chart by drawing one functional component um, for these of the three transforms, right? So one, you have a central transform, and you have efferent branch, and you have efferent branch. So you will have to identify these are the three things as part of your DFD. Okay. So usually how we get this how we do this analysis, usually we will have to identify what are the high level inputs and what are the high level output actually that needs transform that requires some transformation, right? So that is what we really require. So we follow some sort of guidelines. Okay, so there are some guidelines when you going through this transform analysis, right? So what you try to do is you trace the inputs, okay, whatever the inputs that you have, right? Um, so then, you know, so you can think of something like this, okay? So you need a bubble, okay? You need a bubble which can actually transform your input into the output form, okay? That means if you see some of these, let's say, what you say, these sort of processes which validate your input, okay? Let's say you take some input, whether it will say which takes input and it is going to give you some sort of output, okay? So I mean they are actually the central transforms, right? So these are not the central transforms, but still they do some processings, right? So usually those processings are not part of central transforms. Processes which sort input or filter data from it. So like you can see the processes which will take some data and it will sort the something. That means what it does, so let's say you give some input data into the system, and that input data, after taking that input data, it is going to sort all of the input data, right? So that means what, you require a algorithm here, sorting algorithm, right? That means some processing is being done actually into this input data, or you require some filtering of those data, right? So they are actually doing the processing. So they are will be part of some central transforms, okay? So this means they are the measure processings, right? But something validating something, input data or something like that, they are not part of the central transform. So you need to identify that way, okay? So what are the input processings, and which are the bubbles that are involved in, which are involved in just validating the input sort of things, right? And what are the bubbles that are really involved in carrying some central transforms. So that is what we are going to do, okay? So you will have first thing that what you try to do is, whatever the inputs that you have, you start with a first level of structure chart, right? So put a, for each and every input and output units, right? So you draw a box, okay? And then you give some box for the central transforms also, right? So I mean, how we are going to transform this, okay? So what you do is, usually you start with something like this. You try out certain input units and you try out some output units, and you try out, try to find some of these central transforms, right? For each of them you draw a box, okay? Now try to add subfunctions for each and every module, okay? That means whatever the box that you have identified, so part of that particular box you try to identify some functions, sub functions, okay? So they will be actually uh, they will be part of that particular module, okay? So many levels of modules may require to be added, okay? So usually what you do is, so that is the way that you keep on creating some levels of these modules, right? I mean, you first identified the main high level module, okay? And for that high level module, you have just identified some functions, sub functions, right? Required. That means, and then what you will be doing, and then again you will be identifying the sub functions of those sub functions, right? So this is the way that you actually creating many different levels, right? So now we will talk about something called yeah, I think I stop here. Again, I'll continue in the next lecture. That would be better. Okay. Yes. So as of now, any doubts so far, students?
No, sir.
So then what time you have a lecture again?